in the last 10 years, we reduced the cost of computing by 1 million times. The cost of deep learning by 1 million times. If we could reduce the marginal cost of computing down to approximately zero, we might use it to do something insanely amazing. Large language models. To literally extract all of digital human knowledge from the internet and put it into a computer and let it go figure out what the knowledge is. That idea of scraping the entire internet and putting it in one computer and let the computer figure out what the program is an insane concept. But you wouldn't ever consider doing it unless the marginal cost of computing was zero. Imagine, for all the people that are still new to artificial intelligence, we've figured out how to use a computer to understand the meaning, not the pattern, but the meaning of almost all digital knowledge. And anything you can digitize, we can understand the meaning. So let me give you an example. Gene sequencing is digitizing genes. But now with large language models, we can go learn the meaning of that gene. We can understand what's the meaning of a cell. A whole bunch of genes that are connected together. And so this is, from a computer's perspective, no different than a whole page of words, and you asked it to summarize. What did it say? Summarize it for me. What's the meaning? This is no different than a long page of genes. What's the meaning of that? Big, long page of proteins. What's the meaning of that? The chip that John just described weighs 70 pounds. It consists of 35,000 parts. 8 of those parts came from TSMC. That one chip replaces a data center of old CPUs like this into one computer. The savings of that one computer is incredible, and yet it's the most expensive computer the world's ever seen. It's $250,000 per chip. We sell the world's first $250,000 chip. But the system that it replaced, the cables alone cost more than the chip, this H100. We took this entire data center and we shrunk it into this one chip. It works as a team. And so you connect a whole bunch of these things together, and networking is part of it, and it computes at data center scales. And together, what's going to happen in the next 10 years, say, John, we'll increase the computational capability for deep learning by another 1 million times. We go train, inference. We learn, and we apply it. In the future, we'll have continuous learning. The training process and the inference process, the training process and the deployment process, application process will just become one. When you can drive the marginal cost of computing down to zero, then there are many new ways of doing something you're willing to do. This is no different than I'm willing to go further places because the marginal cost of transportation has gone to zero. I can fly from here to New York relatively cheaply. If it would have taken a month, I'll probably never go. People who operate data centers think about the cost of operations. Our time to deployment, our performance, our utilization, our flexibility across all these different applications, in total, allows our operations cost, they call it total cost of operations, TCO. Our TCO is so good that even when the competitors' chips are free, it's not cheap enough. And that is our goal, to add so much value that the alternative is not about cost.